Hey everybody, welcome back to CIS 17A. Today we're going to be covering the last lesson of the semester. We're going to be talking about lesson number 19 on what is called polymorphism. All right, polymorphism is one of the last big features of the C++ language. Now there is other topics that we could talk about outside of polymorphism, like file input and output. There's something called templates that you can use to create things that are like vectors. There's all kinds of other extra stuff. There's error checking. We didn't do any kind of error checking or how to handle exceptions. So those are all probably something that you would see in CIS 17B. So this is where we're going to leave it off for this semester, is on the feature known as polymorphism in the C++ language. All right, so let's go ahead and jump on over to the book. Pages 907 is where we're going to start on polymorphism. All right, so polymorphism, what is that? So polymorphism allows an object reference variable. So let's start off with just that. What is an object reference variable? Let's jump down here to this function. So this is a function called display grade, and we are going to pass it as a parameter a member of the graded activity class, and we're going to name that object activity. So there we go. So an object reference variable is this right here. This is an object, well, this is the class, is graded activity, and this is an object reference variable. Right, so that's the sign for a reference. And more specifically, this is a constant reference to a graded activity class. And yeah, so there you go. So it allows a object reference variable or an object pointer, which we'll see later, to reference objects of different types. So notice that the type in this is a graded activity. And you can recall back from the previous lesson, the graded activity class simply has a score in it. That's it. Right? So it's very general. All right, so and then that was the base class for the other class that was created in the last lesson, which was to create an exam object, I believe, something like that. All right, a graded exam, I think is what they called it. Okay, so down here, let's go ahead and just jump ahead a little bit, and we're going to see that this is going to, final exam. I don't know, the book actually did like 3 or 4 different derived classes of the graded activity class, and we only covered one of them, so I can't remember exactly what that was. But in any case, final exam is a derived class of the graded activity class. So that was the base class, and then final exam is a derived class. And you can see that it takes 2 parameters. The first parameter represents the number of questions that are in the exam, and then the second item or argument is the number of questions that the student missed. And notice here that they're calling the function display grade and passing it the final exam object. But recall that the display grade function up here, display grade, is not passed a final exam object, it's passed a graded activity object. So that's what it's talking about in the second part of this, is that it can allow an object reference variable to reference objects of different types. So those are different types, right? A graded activity versus a final exam. But yet we're still able to do this. We're still able to pass it this as long as it's a reference or a pointer. Okay, so as long as it's a reference, we can do that. Now, just to get ahead a little bit, you can actually make this a literal and get rid of this. It will let you do that in code, but it opens the door for a runtime error that will crash the program. So you should never do that. You should always make it either a reference or a pointer when you're using polymorphism. Okay, so that's the first half of this little blarb. The second thing that it says is that it will allow you to call the correct member functions depending on the type of the object. So we know that we can well, actually, we haven't talked about member function overriding, but we'll talk about that later. So what we can do is inside of a derived class, we can give a member function the same name as a function from the base class, and that will override it. All right. So the problem then is when we use polymorphism is if we do this, if we say that it is a graded activity, how does it know which function to call? Does it call the function in the base class or does it call the function in the derived class? Okay, So we'll see later how we can add some code that allows it to be able to do that. All right. Now, if that doesn't make a whole lot of sense to you, it's okay, because I'm going to spend the next 20 minutes further elaborating on this and giving you some examples as well. All right, so let's go ahead and just run through this first example. So here we have, again, we're passing it a constant reference to an object, a class, a graded activity class, and the object's name is activity. And all this simple little function does is, these are the two main lines of code. It calls the getScore function from the graded activity class, and it also calls the getLetterGrade member function from the graded activity class. So just recall that a graded activity, the only private member variable that it has is a score, and I think it's like a double or an int, I can't remember. But so anyways, it's just a number like on a score between 0 and 100. And then when we call get, so that just returns that number that was provided by the constructor or whatever. And then getLetterGrade, that just converts that number score into a letter grade like A, B, C, D, or F. Okay, so hopefully you remember that from the last lesson. All right, and you don't need to remember how it works. Just remember that returns the numeric score, that returns the letter score for the graded activity. All right, so here down here we're going to create an instance of a graded activity object called test, and we're going to initialize it with the score of 88, and then we're going to call the function display grade, and we're going to pass it. We're going to pass it test. So we're just going to pass that right down there, and then it would result in the following lines of code. We would say the activity. So obviously we're doing some kind of cout statement here, is equal to 88, and then it would say an 88 is equal to a B. Okay. All right, and it's just reminding us that this is a relationship, right? So a final exam is a graded activity. So let's go ahead and declare an instance of a final exam object called test2, and then we're going to pass that to the function test2, and then this is what would actually end up printing out, that the numeric score is 75 and the letter is a C. So it's still working, so we're still not running into any problems. Okay. Now, it mentions here that a problem can occur, however, when a member function has been redefined. Okay, so everything's been okay so far, right? All right. Now here's where the problem comes in. We're going to deal with another derived class of graded activity called pass-fail activity. Now I never reviewed what this looks like in code, but it doesn't matter. All you need to know is this, that pass-fail activity is a derived class of a graded activity class. And the way that it works is you pass it an initialization number that is, as it says here, the minimum passing value. So in any word, in other words, I can't get my words out, with a pass-fail activity, if a student gets a score of 70 or higher, they pass, otherwise they fail, all right? So down here, we're going to go ahead and set the score. So we'll say that the student got a 72, which is greater than 70, so therefore they passed that particular activity. Okay, so hopefully you understand what this function is doing. And then now down here is the critical part. Because we are not returning a letter grade, an A, B, C, D, or F, we're returning either P or F, or pass or fail. We overrided the get, where's that? The get letter grade. So I'm sorry, not overrided it. We redefined it in the pass-fail activity class. So we redefined this so that now instead of returning A, B, C, D, F, now it returns either pass or fail. So what happens when we pass this type of object to our display grade function? Well, let's see what happens when we run it. We get that the numeric score is 72. That was the value we put using the set score function up here, right here. But then when we called display grade and we passed it test, remember test is now a pass-fail activity, the result is that it printed C. So it shouldn't have done that, right? So because it is now a pass-fail activity, it should have either printed P or F. In this case, it should have printed a P because the person passed the test. So what's the problem? Why is this a problem, but we were able to get away with it okay in our exam example? Where's the exam example? So the reason is because in the final exam derived class, we did not redefine the member function get letter grade. So that was not redefined in this class. So that, because of that reason, everything worked as we would expect it to work. But because we redefined it in the pass-fail activity to print P or F, we would expect to see it work, but it's not. So let's get into a little bit of why it's not. Actually, before we do that, let's go ahead and do a quick example of what the book is talking about, so we can actually see it happen in real time. All right, so recall this is the simple example from the last video. I said that I'm going to declare a class called shape, and shape is going to be my base class, and the only thing that a shape has is a color. All right, simple little inline functions here. We got char C, so we're creating a constructor where we require the person to provide a char that represents the color, and then we just simply assign that to C. And then we just got one simple function here that returns the color as a char, like so. Okay, so very, very simple class. And then down here, we wanted to declare a new class called square, which is derived from shape. And we have to use the notation of the colon. We always use public when we use inheritance. And then we're going to say that it inherits publicly from the shape class. So now my square will also have a color. All right. Now recall from the last class that in order to initialize the color, because it's private, I can't just directly access it down here with one of my functions. Remember, I can't just go into here and say color is equal to C, right? It gives me that compiler error because I'm using public base class access, and I declared this private in the base class, so I can't do that. All right, and then also recall that if I change that from private to protected that I could, but remember I give a little lecture on why using protected is not a good idea, why you should, generally speaking, always use public base class access and keep everything private or public. All right, so let's go back here. So we said that the way to solve this is to call the base class constructor using this notation. So after we call this is the constructor for the derived class. So after the constructor for the derived class, we put in the notation of the colon, and then we put the name of the base class constructor, and we can pass it stuff that is passed in as an argument when we call the constructor for the derived class. All right. So this is going to go ahead and jump up here. It's going to do this line of code. It's going to come back here. It's going to set the length equal to 1, so it initializes that. So there's our complete constructor for the derived class. All right, next we only have one function, member function I should say, that gets the length, and it just returns the length of each side of the square object. All right, so there's a quick review for you on that. All right, let's go ahead and create a function that is similar to what's in the book. So this function is just going to print out the length and the color of a, wait, no. This is just going to print out what the object is. All right, so we're going to create a new function in here, and I'm going to make this void, and I'm going to call this who am I. Okay, and then we'll make this inline, and we'll just have it see out what it is. Okay, I'm a shape. All right. Okay, and then let's go ahead and copy this, and we'll also redefine this here in the square class. So now it's going to say I'm a square. All right. So again, this is a function, member function redefinition. All right. So this is going to be the same issue, right, that we mentioned with the pass-fail example in the book. So let's go ahead and create a function called foo. It doesn't matter what it's called. And then this is just to show what the book is talking about. And then we're going to pass in a constant reference to a shape. And we'll just call it S. All right. So again, this is just like the book. We're passing in a constant reference to a shape class object, and we're naming the object S. All right, let's see. So all we're going to do in here is call the whoami function and see if it prints out I'm a square or I'm a shape based on what we pass to it. So let's go ahead and say s dot whoami and then put open and close brackets. Now, this is something that I did not mention that I intentionally left in here. Notice I'm getting an error message, and unfortunately the error message doesn't pop up on your screen, but it pops up on my screen, and it says the object has type qualifiers that are not compatible. So what the problem that's happening here is I'm saying that this is a constant reference to a shape object. And so that means I can't modify the class. I can't modify the attributes of S. But I could potentially have a function, a member function in S that does setting, a mutator. So what this is saying is that, hey, this is supposed to be constant, but I don't know what the contents of your code are in those member functions, and you may actually modify this, so can't let you do that. So the way that we do that is we have to use the keyword const in any functions that we want to be able to use if they don't modify anything. So for example, in whoami, it's not modifying anything, so I make it const. And we've seen that before. Same thing down here. It's not modifying anything, so I should make it const. So I didn't do that in the last class. Okay, now the same thing is true here. This one is constant, right? It doesn't modify anything, it just returns it. And the same thing with get color, it doesn't modify anything, so we should make that const. So I didn't do that last time, but remember, if a member function doesn't modify any of the attributes, then you should make it constant. Okay, so let's go back down here, and you can see now our error message is gone. All right, so very simple class, or I'm sorry, function. So now let's go ahead and test it out and see what happens. So let's start off with the shape object, shape S, and then we have to pass it a color in the constructor. So let's go ahead and put B for blue. All right, and then down here, let's go ahead and call that function that we just wrote called foo and test it out. So foo, and we're going to pass it S. Okay, so hopefully that all makes sense. Declaring an instance of a shape called S, initializing it with B, I'm going to call this, and all it's going to do is it's going to call who am I, and it's going to print out, or it should print out in this case, I'm a shape. So let's go ahead and see if it works. F5, run it. And it says, oops, I'm a shape, but we didn't put a new line after that. I thought I did. Oh, slash M. Slash N. There you go. Slash N. Okay. Let's try that one more time. Okay, I'm a shape. All right. Now let's go ahead and change this into a square. Okay. And for a square, it needs to be passed the length of the square. So let's put an arbitrary number and the color. Right, so the constructor wants the length of the square plus the color. And then we're going to call our same little function foo, but this time we're going to pass it the square. So this time we want it to say I'm a square. We want it to use this member function right here. Let's push F5. And it says I'm a shape. So this is the same problem we just saw in the book, where when they called display grade, it didn't return P or F, it returned a C because they put in 72 for the score. So hopefully that makes sense why this is an error message. And this text is small. I'm going to go ahead and fix that. Okay, that's better. All right, so I'm a shape. So even though we passed it a square, it printed out that it thinks it's a shape. All right, okay, so a couple things that we saw going on there. So first off, number one, this is what it mentioned at the start of that explanation of polymorphism, that you can use a object reference that takes a different type. So we're taking a type square and we are now converting it into a shape, right? So that's part of polymorphism. Now again, in order to do that, it has to be a derived class of that base class. You can't, just put like you can just put like any random class in here. It has to be the case that you are passing a derived class up into this, and this is the base class, all right? Okay, so that's number one. But now we're seeing the problem is that if we redefine a function, who am I, redefines this, that it incorrectly prints out I'm a shape. Okay, so how do we fix that? And the book explains a little bit. I guess I could explain a little bit of what's happening here. The problem is when you, we'll see in a moment that we need to use the keyword virtual to make this behave properly. Now when we don't use the keyword virtual, what happens is the piler does something called static binding, which happens at compile time. So what happens is here, when we compile this, because this whoami member function is not virtual, it does static binding. So anytime it comes up here and executes this code, it treats S like it was a shape object, no matter what it actually is. So it ignores the fact that it's actually a square object, and it uses the member function from shape. That's static binding. Now, when you use the keyword virtual, it does something called dynamic binding, which is similar to when we call the new keyword to dynamically allocate memory. So there's that word dynamic again. And the word dynamic is always associated with something occurring during runtime versus at compile time. So when you do dynamic binding via the keyword virtual, the compiler will hold off binding that function call until the program is actually running, so that when the program is running and it hits that line of code, it will look and see, okay, what type of object are you? Are you the base class or are you the derived class? And then based on that information, it will correctly call the right function. And simply put, all you got to do is put the keyword virtual before the return type of the function. All right, it's that simple. We add one word, right? All right, so let's go up here, and a couple things worth mentioning. Whenever you make a function virtual in the base class using the keyword virtual, it automatically becomes virtual in the derived class. So I don't need to put the keyword virtual here, but as a common practice, most programmers do put it there for clarity. So it's optional to put it down there. It's kind of like how in the prototype you don't need to put the, there's no prototype here, but it's kind of like how in the prototype for a function, you don't have to put the name of the parameter, you just have to put the type, right? So anyways, okay, where am I? So let's go ahead and try this again. So this time we've made our function virtual. So now the compiler is not going to do static binding. It's going to hold off when it compiles and say, I gotta wait till this code actually executes, and then I can resolve which function to call. So let's run it again. And this time it says, I'm a square. All right, so there you go. That is dynamic binding using the keyword virtual, right? So just so we can see this one more time, see how it goes back and forth. Let's change this back into a shape now. Okay, and then let's run it again. And it knows now that it's a shape. So that's what the keyword virtual does. It allows it to do dynamic binding and figure out what type of object you are at runtime. All right, let's make sure I didn't miss anything. Looks good. Looks like we got everything covered. All right, so the next thing that it mentions is that you place the virtual keyword in the declaration only, that if you're using separate files, if you have a header file and a .cpp file associated with it, that you do not use the virtual keyword. You only use the virtual keyword inside of the header file where you have your function prototype, okay? I think you'll get a compiler if you try to put virtual before the definition in the CPP file. All right, so let's move on. So now all they're going to do is rewrite the graded activity class to make getLetterGrade virtual, and they're going to do the same thing for the pass-fail class to make it virtual. So now we should expect that when we call that getLetterGrade member function, so here they're just going to go ahead and the exact same code as the example above, but now when we run it, we can see that it correctly gives us P instead of C for this. All right, so hopefully that's makes sense what the book is doing here. All right, and then it mentions the term polymorphism. That just means to take many forms. All right, and we can see that that's kind of what's happening, right? It's a pass-fail exam is going to polymorph or change into a graded activity when we are passing it to the function, right? And then it is changing when you call display grade, or I'm sorry, when you call getLetterGrade, it is changing what it does or polymorphing into the member function of the correct thing, okay? All right, and then here, this is just another example where they're showing you everything in one. So here they're just declaring the graded activity, declaring the pass-fail exam, and they're just showing you the same thing that we've already seen, that you can call the same function display grade. This time we pass it the graded activity, this time we pass it the pass-fail, and that it behaves properly again, right? 75, we pass. Okay, so they're just showing you more of the same thing. All right, as mentioned in the at the start of the chapter, polymorphism requires that you use a reference or a pointer when you do it. Okay, and then here it mentions that you can write code where you don't do that, where you don't make it a reference. So we know we should have a star here. I'm sorry, an asterisk or an ampersand symbol here to make it a pointer or a reference. That this won't crash unless the person actually tries to use a function that is not in the what am I trying to say? So if the derived class, how do I say this? Okay, so after pausing the recording here for a second and reading through this, um, this is another example in the book of it saying like, hey, you can do something, but you shouldn't do something. And I'm just going to, instead of reading through this and wasting time explaining, I'm just going to leave it at this. Polymorphism requires references or pointers. You don't really worry about all the stuff that's in here or this example, right? It's just leave it at that. Okay, let's move on. Base class pointers. Now in the previous examples, we used references for everything. Now it's worth noting that that's actually not very common. When you do use polymorphism or virtual functions, it's far more common to use pointers than it is to use references. So the next thing the book is going to show us is just an example of polymorphism using pointers instead of references. All right, so let's go ahead and see what we're doing here. So this time we are going to create a new pass-fail exam object, and we're going to pass it these things to initialize it, and it is a pointer instead. And because it's now a pointer, the only difference is that, remember, when you called the member functions, you use the arrow operator instead of the dot operator. All right, let's look at an example of another program. So we're going to declare a constant numTest and set that to 4. It's because this time we're going to use an array of graded objects instead, or graded activities instead of just separate instances. So down here, we're going to declare a pointer to a graded activity and call it tests, and that's going to be an array with 4 things in it. Recall back when we talked about objects and arrays, that we said that when we initialize them, if we have more than one argument in the constructor, that we need to actually call the constructor when we pass it in. And this time, we're also going to dynamically allocate it. So we're going to use new graded activity. That's the constructor. And then that's going to initialize the first element of the array. And again, down here, notice we're assigning one type to a different type. So pass-fail exam is the derived class, graded activity. So this is going to initialize the second thing in the array. This is going to initialize the third and the fourth. Okay, so we have an array of 4 graded activity objects, but it's not actually graded activity. It's a mix of pass-fail exam and graded activity objects. All right. Next, we're going to look at the display function. It's the exact same display function as before, with the exception that this is now not a constant reference, it's a constant pointer. And because of that, we're going to use the arrow notation to call the member functions. All right, down here, because it's an array of 4 different things, we're going to use a for loop to call that function 4 times. So we're going to go ahead and say this line right here, graded, display grade, tests, that's the name from here. And count is our iterator in the for loop. So it's going to call grade, display grade 4 times, and then put a line between each one. So it would look, when we run it, like this. This is an 88 as a B. Remember the second thing was a pass-fail, so this one's going to be P. The third thing was a regular graded activity, so that's a D. And then last but not least, or was it a final exam? Can't remember. It's a graded activity. Okay. And so that's 67, and that's a D, and then last, this is 76, and it's pass. Okay. All right, so they're just showing you that in this so that's a pretty big deal. So the cool thing here, and this is how you see polymorphism used a lot, is you have a for loop, and you have an array, or like, it's usually not an array. Well, I shouldn't say it's usually not an array. It could be an array, it could be a vector, it could be a linked list, but you're going to go through and you're going to call the same function on each element and use polymorphism to figure out what the correct member function is to call. All right, so this is a very, very common structure to see when using polymorphism. Okay, let's move on down to here. Here, I think they're just going to explain everything that I just explained, right? Okay. All right, so let's move on to here. Base class pointers and references know only about base class members. Okay, all this is saying is that when you use polymorphism, the assumption is that you use virtual and that you uh, redefined the, we'll see later that they get picky about the terminology, overriding versus redefined. So technically you're not redefining the function, you're overriding the function. We'll see that later on though. But again, that's just terminology. It doesn't matter. It's more important that you just that you understand what's actually happening. All right, but anyways, going back to this. A graded activity only has these member functions in it, get score and get letter grade. Now, a derived class we know could have in any number of extra member functions that are added to it, right? That's the whole point of inheritance. But the point it's trying to make here is that get points each does not appear anywhere in graded activity. So even if you try to use polymorphism, this isn't going to work. But remember that in order to make a function virtual, you have to use the keyword virtual in the base class, right? So yeah, so that should hopefully make sense. That if you try to call a function that does not exist in the base class, then you'll get an error. It won't work. Okay. All right. The is a relationship does not work in reverse. Yes, that is true. So what are we trying to say here? We are declaring a graded activity pointer called GA pointer, and we're going to give it a dynamically allocated graded activity. That's fine. That's okay. But we can't do this. We can't say, here's a pointer to a final exam object, which is a derived class of graded activity. And we can't say that the base class is now going to be assigned to the derived class. So you can't do that. You can always assign the derived class to a base class, but you can't do it the other way around. That's the whole idea of an is a relationship, right? So like a final exam is a graded activity is true, but a graded activity is a final exam is not a true statement, right? Okay, so they're saying you can't do it in reverse. Okay. Oh, and then this, I don't like it when the book does this. This is more of an example of like, hey, this will work, but you shouldn't do it. So I'm just going to tell you guys, don't static cast a final exam. Don't make this a graded activity, but then static cast as a final exam and then assign it. The compiler will let you do that, but then again, you'll potentially run into problems later down the road. So don't do that. All right, redefining, and this is what I was saying. The book kind of gets into terminology, which is, I guess it's okay to, or it's important to know terminology, but it's not like, at the end of the day, as a programmer, it's more important that you know what the code actually does, right? So they talk about the difference between overriding and redefining. All right, so overridden functions are dynamically bound. So that was like earlier when I did the who am I example with the member function called who am I is in the shape and who am I in the square. If you don't put the keyword virtual, then you are overriding the function. If you put the keyword virtual, now they don't call it, in terms of terminology, they don't call it overriding, they call it, where's the word? Overridden, yeah. So, um, oh wait, did I say that right? Overridden functions are dynamically bound, and I'm trying to read this and think at the same time. Okay, I think I said that wrong. All right, so the terms are overridden and redefined. So overridden is what we call dynamically bound functions that use virtual. Redefined functions are statically bound. Okay, so those are functions that don't use the keyword virtual. Again, this is just terminology, right? Okay, moving on. Virtual destructors. Okay, so um, we run into another problem when it comes to calling a destructor with dynamically allocated stuff. So let's move down to the example down here and just take a look at the example because this explains it pretty clearly. All right, so we're going to have a class called animal, and all an animal class does is when the constructor is activated, it prints out animal constructor executing, and then when the destructor, remember if it has a tilde, it's a destructor, When the destructor runs, it just says animal destructor executing. Dog is going to be a derived class of animal, so a dog is an animal. And then here we say dog constructor executing, dog destructor executing. So it's a pretty simple program. Down here in main, we are going to declare a pointer to an animal and dynamically allocate it as a dog. Okay, so we're assigning a dog to a animal pointer. And then we're going to call delete on my animal. Because remember, anytime you call new, somewhere you should have a corresponding delete that gets rid of the thing that you dynamically allocated. And then this is what would actually happen. It's going to say animal constructor executing, dog constructor executing. So we're okay on the constructor side of things, but when we get to the destructor, you can see the problem. It's not calling the destructor for the dog. Even though we totally defined it here, it doesn't execute. And that's because we need to use the keyword virtual on the destructor so that it can figure out that it needs to call the destructor for the dog first, then the destructor for the base. So remember with constructors and destructors that with inheritance it calls the constructor of the base, then it calls the constructor of the derived. But when you're calling the destructor, it does it in reverse. So it'll call the destructor for the derived object, then it will call the destructor for the base class last. All right, so in order to get it to do that, once again, we got to make this a virtual destructor. So all we're going to do is add the keyword virtual in front of the destructor. Okay, and then again, you don't have to put it, but it's optional. Remember, anytime you, as I said earlier, anytime you use the keyword virtual in the base class, it automatically becomes virtual in all the derived classes. All right, so now we're going to run the same thing, dynamically allocate a dog, assign it to something of type animal, the base class, and then delete the animal. And this time we should see that it correctly executes by saying animal constructor, dog destructor, which wasn't there last time, and now animal destructor. Okay. All right, so that's important. We'll see that later for the lab that we're going to need to do that as well in order to dynamically not dynamically, but in order to correctly deallocate all the memory that's allocated. All right, and we're actually almost done. So the last topic is, and last topic of the semester, yay, is something called an abstract base class and something called a pure virtual function. Okay, now an abstract base class cannot be instantiated. In other words, you can't declare an instance of something that is an abstract base class. But other classes are derived from an abstract base class. All right, so let's go ahead and just move on. A pure virtual function is a virtual member function of a base class that must be overridden. Okay, so remember that when we override something, we give it the same name as the function in the base class, but we put the word virtual in front of it. When a class contains a pure virtual function as a member, that class then becomes an abstract base class. In other words, if a class has a pure virtual function in it, it is then considered an abstract base class. Okay? All right, again, if that's confusing, it's okay. We'll take a look at an example. And this, I read through this example earlier. It's terrible. Don't even read it. All right, so how do we make something a pure virtual function? All we do is this. In the declaration or the prototype, you add equals 0 just after the name of the function. And that's it. By adding this, you're indicating that that is a pure virtual function, and therefore that the class that is contained in is an abstract base class. So remember, if one or more member functions of a class are pure virtual, as they call it, not just virtual but pure virtual, then it is now considered an abstract base class, and we cannot declare an instance of that base class. All right, so maybe think, oh gosh, I remember this example, it's really long. All right, so you may be thinking to yourself, well, why would you do that? And why would you write a class and then not create a definition for the class? And the answer is that it's actually very useful, because think of something like a shape, like the example that we've been doing. So a shape has a color, right? But let's say that we want to draw the shape. That may be like, and that's what we're going to see in the lab, something that we want to do. Well, a shape object has no idea what kind of shape it's going to be. It doesn't know if it's going to be a square or a circle or a rectangle or whatever. So, but we do know at some point that we're going to want to draw it. So that would be a good case for a pure virtual function. And that's why it would be considered an abstract base class. So a shape is rather abstract, right? So it's actually more common than it is not to, when you're using inheritance and polymorphism, to use abstract base classes and pure virtual functions. All right, so let's go ahead and move down here to this student class. Okay, now hang with me. This is a kind of long example, but it's, hey, it's the last one of the semester, and then you survived. Okay, so student. So a student has a name, an ID number, and a year that they started school. Okay, so we're defining our, this is going to be our base class, student, and this is the default destructor, just initialize everything to 0. Here's our constructor that requires that the person pass in all the information when they declare the instance of it. And then we saw this earlier in the last lesson. Instead of him just directly initializing all this stuff, he writes a set function that does it indirectly, right? So name, ID number, year admitted, that gets passed to the set function from the constructor, and then he initializes everything here, right? So I guess that the thing that's kind of nice about this, instead of just doing it right here in the constructor, is that you have a set function that you can call to set that information outside of the constructor if you wanted to do it that way. So you could use the default constructor the first time you declare it, and then somewhere at some point later on you could call the set function. So that's one reason that you might want to do it this way instead. Okay. Simple returns those values from the, simply returning the values that are contained in the class, and then a pure virtual function called get remaining hours, kind of a cryptic sounding name. What this is going to do is it's going to return the number of hours left that they need to complete to graduate from school, all right? And I know that's rather abstract, right? But just for this, to make this example simpler, that's probably why he did it this way. All right, so using equals 0 here means it's a pure virtual function and that this is not going to be defined anywhere. Well, it's not going to be defined here. It's going to have to be defined in the derived class. Okay, so let's see. So now we're going to create a something called a computer science student. And then, because we could have all different kinds of students, we could have biology majors or chemistry majors. This is going to be a computer science major. All right, and we are going to make this a instance. I'm sorry, not an instance. We are going to derive from the student class. So we'll get our name, ID, and I can't remember what the third thing was. The year they got admitted, I think, was the other thing. Okay, and then a computer science student is going to have specific classes that they need to take, like a math class, computer science class, and then general ed class. And these are going to hold the number of hours that the student has currently completed in those classes. Here's our default constructor, setting that to 0, and then we're using that ID or that notation right there. Remember, that's going to call the constructor in the base class and initialize those all to 0. Or we could pass in values for the student and then pass those along to the constructor here. So n gets passed over here, ID gets passed here. So this is going to call the constructor for the base class student, and then it's going to initialize all the hours for their particular classes to 0. So we're going to start off with no hours set. These are going to allow us to modify those values and update them to whatever the student currently has. All right. And then finally down here, we are going to override the pure virtual function, get remaining hours. And we're not going to do that here, but we're going to do that in a separate .cpp file, as it mentions here. So let's go ahead and look at that. So here's the .cpp file where we override, make sure to use that right word, we override, not redefine, we'll get in a lot of trouble. So we're going to override that pure virtual function like so. So we're going to create some placeholders here, int regular hours and remaining hours, or required hours and remaining hours. And required hours is equal to the sum of these three constants. Where were those defined? Math hours, CIS hours. Oh, here they are. So these are global constants, okay? So global constants, this is the number of hours that they would need to complete before graduation, okay? So again, global constants aren't bad. Okay, so we're using those global constants down here. And then the remaining hours is the total number of required hours, which we calculated here, minus what they have completed so far, okay? And then we simply return that. So that is our overridden virtual function. So why does this, so what is it, why does this matter? So we said that there could be a biology student or a chemistry student, and they're going to have to take different classes. So those global constants would be different for them, right? So they would have like, biology hours or, chemistry hours. And then those would be used down here in the overridden function instead, right? So that way when we run the code, let's see, and I think they're just going to use the example of the CS student. So down here, it would just make it so that we can dynamically call the correct get remaining function based on that student. All right. So hopefully that makes sense to you guys. And again, if it doesn't, that's okay, because we'll talk more about that in the example. And here's the last chunk of reading, you guys. Congratulations, you survived. When a class contains, and this is just a summary of everything we just said. When a class contains a pure virtual function, it is now an abstract base class. That's the notation we use to make it a pure virtual function. You cannot declare an instance of an abstract base class. So in other words, I can't declare in main, where's main? There, main. I can't declare an instance of a student. I can only declare an instance of something that is derived from the student, like a CS student, okay? Pure virtual functions have no body or definition in the base class. They are defined in the derived class. And a pure virtual function must be overridden at some point in order for it to become non-abstract. All right, you guys, so there you go. All right, let's go ahead and switch gears here. Let's go. So that's all the reading, everything we're going to talk about. So let's switch over to the lab. All right, what is the lab assignment? So the lab assignment is going to be to create a program. Let me just go ahead and scroll down here, where we do this. The program's going to print out a menu. And if the person chooses 1, then they're saying they want to create a square. If they choose 2, they're saying that they want to create a rectangle. And if they say 3, they're saying that they want to print all of the shapes in the vector. So every time we create a square or a rectangle, we store it in a vector. All right. Now, when we print the shapes, they're going to print like so. So when we create, for example, a square, the person is going to have to provide to it the color of the square and the length of the square, and it will print like this. So in this example, we have 5 R's. So that means the person said that the square was a red square of length 5. And so it's going to print out a 5 by 5 square. Now, unfortunately, because the letters are not square, it's not going to actually be a square shape, but that doesn't matter. It just has to be 5 things this way, 1, 2, 3, 4, 5, and then 5 things from top to bottom, 1, 2, 3, 4, 5. So this is printing out a red square, right? Now, they can also make a rectangle. Now, a rectangle has a length and a width. So in the example here, it's saying a blue rectangle with length 8 and with width 3 would look like this. So the length was 8. So this is, this is 1, 2, 3, 4, 5, 6, 7, 8, and width 3. So 1, 2, 3 things from top to bottom, and B for blue. All right. So if the person, for example, had put entered 1 square, 1 rectangle, and put those values, and then chose 3 from the menu to print, it would print out this first, and then you'd put a space between them, and then print out this second. Okay? And then last but not least, the person can choose to obviously quit the program. All right, so let's start off with the code to print the menu. That's exactly the same as the code in every other program I've assigned to you guys where you had to print out menus. It's a do-while loop, and then it's an if-else-if structure inside that corresponds to each choice that the person can potentially make. And then obviously you're going to have some cout statement here that says please enter choice, and then the person's going to enter a number 1, 2, 3, or 4, right? And then you say if the choice is equal to 1, do this. If the choice else if the choice is equal to 2, do this. Else if the choice is 3, do this. Else they chose to exit. Okay, in which case you would just set the parameter in your do while loop to false, so that it stops looping. All right. So you guys have done that before, so I'm not going to demonstrate that. All right. Okay, so let's go ahead and go back over to here, and let's go ahead and add some more stuff to this. So let's get rid of the who am I stuff. Okay. we can get rid of that too. So let's start off with the person choosing one. So again, inside here you're going to have a big do while loop, and then inside of that an if else if, and then we're going to have if choice is equal to 1. They want to make a square. So how do we do that? All right, so first off, you're going to have to get the length and the color from the user. So I'm going to leave that up to you guys. It's cout, cn, right? Cout, what is the length? Cn into some variable. What is the color? And then cn that into some shape, all right? So that's simple. All right, so then next we would need to declare a pointer to a shape, because it says in the description, it says, no, I was right. Okay, and then, yeah, up here. Okay, so shape will be an abstract base class with only a char that represents its color, and it will have a pure virtual function called draw, so we'll add that later. Okay, and then where do I, the vector? Oh, right here at the top. Yeah, you're going to add to a vector of pointers to shapes. Okay, so we're going to add to a pointer of shapes. So let's make this a pointer, and we'll call it temp. Okay, this is equal to, and we'll just make it a new shape. And we know that the shape needs to get passed some color. All right. And we said that that's going to get stored in a vector of pointers to shapes. So outside of your do while loop, one of the first things that you'll declare in the main is that you'll declare that vector. So if we're going to use a vector, we need to include the vector class. It always does that. It adds that class in vector. Okay. So again, this is going to be one of the first things you declare. And it's going to be a vector of pointers to shapes. And then I always call my vectors v for some reason. I don't know. All right, and because I didn't put anything out here, it's an empty vector, which was what we want, right? Because we don't assume that there's anything in there. The user gets to enter as many things as they want, or they could just hit 4 and quit in case it's fine. All right, so there's our vector of pointers to shapes. Okay, so again, this would be back inside of if choice is equal to 1, get the length, get the color, and then we declare a new instance, and we pass the did I say? Oh, I shouldn't be saying shape. I should be saying, what am I saying? Shape. Oh, yeah. Okay, sorry. So square. There. Okay. And then we get the, like I was saying a second ago, so we get the length, we get the color into variables, and then we pass those into the constructor for the square. And remember, this is the whole deal, right, with polymorphism. This is the base class, and we're assigning it a pointer to something from a derived class, just like we explained at the very beginning with the who am I stuff, okay? All right, and the next thing we need to do is we need to add that to our vector. So we're just going to simply say v.pushback and pass it temp. And that will add the vector to our, or add the square to our vector of pointers to shapes. All right, so hopefully that makes sense. That's not too complicated. All right, so the next thing that we would need to do is call our draw function. Okay, and I said in the description here that that needs to be a pure virtual function. So let's do that. So shape should always have the ability to draw, so that's going to be a void. And then we call it draw, we call it draw. Okay, and then it's going to be a pure virtual function, so it gets equal to 0. And of course, we need to make that virtual, like so. All right, so now this is so shape now just officially became an abstract base class with this as its pure virtual function draw. So now down here, if I try to declare an instance of a shape, I would get an error message. Now you may say to yourself, why can I do this then, right? Remember, that's not an instance of a shape, that's a pointer to an instance of a shape. That's why we can do that. All right, and because I haven't finished defining the pure virtual function, I need to do that down here. Okay, so we're going to say that this also has a virtual function called draw. Okay. And because the draw function is going to do a lot, I can't do it inline because there's more logic that has to go into it. So I'm going to actually go ahead and define it right down here. Now we're getting into the point where I'm kind of being bad. I've been putting all of this in one file just to make it easy to demonstrate to you guys so that I don't have to constantly click between header files and source files. But you guys shouldn't do it like this. And you're not going to be able to do it like this in the real world because your code's going to be much more complicated than just simply setting things and returning things, right? So just again, in this, for the sake of simplicity, I'm going to go ahead and put the function member definition right here. But in reality, you should be putting this in a header file and then whatever's here in a separate source file. All right, so let's go ahead and do that. So draw does not return anything. It's a member of the square class, and the function is called draw, and it's not passed anything. Okay. All right, and then down here is where we're going to add our code to actually draw the square. So how would we draw the square based on the length and the color? First off, we would need to get the color of the square. So now because that's a member, remember that's a private member of the shape, so I need to use the getColor function, member function, to get that value. Whoa. Right. So I can't just say char c is equal to color, right? Okay, so it gives me the red square line, so I got to say char c is, I guess I could call it color. I can't see. Color, there we go, is equal to get color. All right, so we're just simply calling the public member function getColor. So remember, we can do this, right? So because getColor is public and we use public base member access, this is available to us, but this is not. So we're just using getColor to assign the color of the square here. Okay, next we're going to use a for loop. And then here we can directly use length because this is a member function of the square class, so I can directly access the length. So I is less than the length, I plus plus. Okay, and then here we're going to have another for loop. So what we're essentially doing here is printing out, oops, what did I do? Copy. So here what we are essentially doing, so it happens when I try to think, talk, and code at the same time. All right, so what we're essentially doing is using the inner for loop to print out length number of chars, right? So it's going to go B, 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 B. And then it's going to come out here, and it's going to say, oh, we got to go again, B, 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 B. Got to go again, B, 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 B. Got to go again, B, 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 B. So it's going to print out the same square shape that we see here, all right? So hopefully that makes sense. So we're going to just see out the color. And then at the end of printing out that line of B's or whatever else the color is, we need to put a new line. All right, there we go. So that's going to be your draw function for a square. All right, so we added temp. So we're still going back here. We're still in this would actually be the end of choice one, really. So at that point, you've created the square and you're done, right? All right, so let's go ahead and just test this out. Just test out the draw function. So let's go ahead and actually let's say that we're now in choice number 3, which was to print all objects in the vector. All right, so what would that look like? So this is where we could use a for loop again. And this, I'm going to cheat because I know that it's 4. So I'm just doing this to demonstrate how you would. So in the draw function, you would, or in the choice 3, you would have to call, let's see. Let me think for a second. I'm glad I thought for a second because I'm doing this wrong. Okay, you use the size of the vector, right? So we're in choice 3, print the vector. So we're going to use the size of the vector. So v dot size. Okay, and then this is I love this with polymorphism. Look how simple the print function is. All you do is say v I, and because this is a pointer, we're going to use pointer notation, and then we just call draw. Boom. That's the entire function. Not the entire function. That's the entire code for choice number 3 to print the vector, right? Because it's the draw function, member functions, that know what to do to properly draw a square versus a rectangle. All right, now there is a problem here that I've dynamically allocated this stuff and I'm going to have to delete it. But before I do that, I just want to demonstrate that the draw function works. So let's go ahead and hit F5. And we can see that we get our blue square 4x4. All right, let's play around with this. Let's go ahead and add another new another thing to this. So let's go ahead and say now we're going to say temp is equal to, and you guys shouldn't do this. I'm just showing you how it will work if there's more than one thing. So temp is equal to new square. But this time let's make it red and let's make it 6 by 6. And then let's go ahead and do the same thing. And push back temp. So now the vector will automatically increase to size 2. And then, oh yeah, I guess we should put an inline after that too, huh? Did I put the inline here? Okay, yeah, let's put one here. All right, so see out. So that way we have a space between each square or rectangle. All right, so now we should get 2 squares. There's our blue square, size 4, and there's our red square, size 6. All right, so that's what number 3 will do, is it'll print out all the things in the vector. Okay, and then last but not least, I said that we need to delete stuff. All right, so that's going to be yet another for loop. Okay, and we're going to delete each thing in the vector. And that's it. Well, it's not really it. Okay, now notice I don't have a destructor for these. And recall that with the destructor with that animal example, that if it's not a virtual destructor, it only deletes the thing from the base class and it will never delete the thing from the derived class. So that's the last thing that we need to do. I think they mentioned that here, is that you need to, is it here at the bottom? Yeah, when they choose to exit, you need to call delete on each element in the vector. For those delete operations to work, the destructor must be virtual. All right. Okay, so let's go back over here. So let's make a destructor called shape. And because nothing inside of this is dynamically allocated, I don't need to do anything. Right. So if there had been something dynamically allocated up here, like if I had a pointer to something and it was dynamically allocated, that's where I would need to go into here and call delete on it to make sure that it all gets wiped out. All right, so let's go ahead and add, oh, and I gotta make it virtual. There we go. Okay, and then same thing, we'll add the destructor for the square. And again, I don't have to put virtual, but I'm just doing it to be clear. And again, it does nothing because nothing's dynamically allocated to it. All right, but let's go ahead and do this just so we can see it. Let's just print out so we can actually see that it's happening. We're almost done, you guys. All right. Semicolon. All right. And we're going to make this a square. What it? I'm not paying attention. Oh, yeah. I don't know what I'm doing. All right, deleted square. There we go. All right, so a virtual destructor, and then I guess just for the sake of, why not? Why don't we do that? Just for the sake so you guys can see it. Let's go ahead and not make it virtual, just so you can see it does the same incorrect thing. All right, so let's go ahead and just run it. This time it's going to delete each thing after drawing everything. And notice what we get down here. Deleted shape, deleted shape. So it called delete for the base class, but it did not call the destructor, even though we clearly wrote one. Right here, deleted square, it did not call the destructor for the derived class because we didn't make it a virtual destructor. So that's bad. So that's a potential memory leak right there. If I declared anything dynamically in here, it would never have gotten deleted, and again, that can cause problems. So we make it virtual. And now, when we run it, deleted square, deleted shape, deleted square, deleted shape. Now it worked properly. Okay. All right, you guys. So I'm not going to write the rest of the code. I'm going to leave it up to you guys to figure that out. But again, in summary, let's go ahead and go back to here. So I showed you how to write the overridden version of the draw function for a square. You're also going to need to write the overridden version. And if you guys want to put it in all in one file like I did, go ahead and do it. But yeah, I guess, because then I have to make the assignment turn into zips. I guess I could make it accept both. I'll leave it up to you guys. If you want to separate everything out into header and source files for the, so you'll have one header file for a shape, two header files, one for square, one for rectangle, and then you'll have two source files, one for square, one for rectangle. And then you can just zip that all up and turn in all those files. Or if you want, you can just put everything in main, like I'm doing here, and then just submit the main.cpp file. So then you're going to have to do oh, I didn't even define the rectangle class, so it's going to give me all kinds of error messages, but it's okay. So obviously I need to do that. Obviously I need to create a class called rectangle that publicly inherits from shape, and it's going to have, instead of just a length, it's going to have a length and a width. It's still going to have a constructor. This time, however, the constructor is obviously going to take three things: the length, the width, and the color. And then you're going to have to do the same thing. You're going to call the constructor for the base class. And then over here, you would just initialize the length and the width for it. Okay. It's going to have a virtual destructor called rectangle. And then you don't do this. You don't need to actually do that. So the destructor doesn't do anything. Okay. And then let's see. Where was I? Oh, the definition, the class member definition for the rectangle. All right, so yeah, you would initialize the length and the width, the destructor. It's going to have a get length and a get width function. Now you actually don't need those. Yeah, you know what? You don't even need those because you're going to be accessing these from within the member function, and that's allowed, right? Obviously, a class can access its own private members from its own member functions, so you don't even need that. And then the draw function would look very similar to this for the rectangle. It would just be void rectangle draw. And then inside here, the difference is that you would have one loop that prints the length and then one loop that prints the width based on the way that I showed you on the example here, right? Okay. So I think that's it. All right. And then again, this would be outside of the do while, because I didn't finish that. So this would be outside of the do while loop. The next thing would be the do while loop. This would be choice one. This wouldn't be there. This would be choice number two. All right, and then this would have to come after you exit the do while loop. You're going to delete the vectors. Okay, And that is it. Hopefully that's enough information. I've pretty much given you about 80% of the lab assignment. Hopefully that's enough for you to figure out how to solve this. If not, you can always send me an email and let me know what error. That's what you guys have been doing. You've been sending me like screenshots. That's really helpful, by the way. If you, some of you just send me your code. But if you send me the code, your code and the error message, the specific error message, like a screenshot of the specific compile message, or you can even just copy and paste the compiler error into your email, and that's usually more than enough for me to figure out what's going on and why you're having problems, okay? All right, you guys, last video of the semester. Hopefully you guys learned a lot and it wasn't too frustrating for you. The last thing that I want to mention is, I don't know if everyone's aware of this, because I have had people ask me, like, I've had students that are concerned about their grade in the class. This semester, the college is making a special exception to dropping the class. So you can actually take the entire class, you can get a grade in the class, and then you can just totally drop it, and the grade won't count towards your official record. Okay, and I'm going to be putting some information up on the class, on the Canvas website on how to do that later on. Okay, so even if you're like, man, I totally bombed this class this semester, it's okay. You can drop it, and your grade won't count towards you. And then hopefully the next time around that you take this, just based on having survived through these 16 weeks and the things you have learned, hopefully it'll be much easier for you the second time around. All right, so that's it for today, you guys. I hope everybody's staying safe and healthy, and I'll talk to you again soon.